Um, Good morning, everyone. I am we are the group 3 and we are going to report the equipment and manipulation for filtration. So to begin, we have these objectives. First is we will be able to know the difference or comparison of filtering media for gravimetric analysis. So later on, we will be one of our reporters uh, will be able to compare the difference of the filtering media for gravimetric analysis. Second is to demonstrate how to prepare crucibles, preparing a filter paper, and filtering washing precipitate. Later on, we will also be um, presenting different videos for this one. And for the third is to define precipitate, differentiate gravity filtration, and vacuum filtration. Later on, we will be answering the different guide questions given for this activity.
So we have here the different, am I audible po? Okay po, thank you. So we have here the different filtering medias that we used for gravimetric analysis. So for the first one is the filter paper. In terms of its speed during the process of filtration, paper is kind of slow. It is because there might be some small particles that will clog the filter paper during the process. And using filter paper is also inconvenient and troublesome. Paper doesn't also have maximum ignition temperature. So, and for the chemical reactivities, since paper is an organic compound, there is a presence of carbon, and carbon has a reducing property. While for the porosity, paper has so many holes. It can also accommodate gelatinous precipitates, and one of advantage of using filter paper is that it is actually cheap. So for the next one, we have here the different kinds of crucibles including Gooch crucible, or also called glass mat, and glass crucible. In terms of their speed during the process of filtration, both can actually filter rapidly. They are also convenient to use, while in terms of temperature, Gooch crucible can withstand more than 500 degrees Celsius, while glass crucible can withstand from 200 degrees up to 500 degrees Celsius. For the chemical reactivity, Gooch and glass crucible are inert, and when we say inert, it means that they are chemically inactive or they don't react to the different kinds of chemicals being filtered. For the porosity, both of them have small holes, but it's very few. While for gelatinous precipitates, there might be a tendency that it will clog if you use crucibles. And lastly, another disadvantage of crucibles is that it is too expensive compared to filter paper.
So porcelain crucible next, and aluminum oxide crucible. So porcelain crucible and aluminum oxide crucible, they look similar but different ignition of temperature. They both crucible that contain constant mass within the limits of experimental error and are used principally to convert precipitate into a suitable weighing form. The solid is first collected on a filter paper. The filter and contents are then transferred to a weighing crucible and the paper is ignited. When it comes to their speed of filtration, they are both rapid. Convenience and ease of preparation are both convenient to use. But in maximum ignition temperature are not the same. Porcelain crucible can be used up to 1,100 degrees Celsius, while aluminum oxide crucible can be used up to 1,450 degrees Celsius. Chemical reactivity are both inert, means they don't really react to the chemical being filtered. Porosity is several available, and convenience with gelatinous precipitate is unsuitable, and filter tends to clog, especially with gelatinous precipitate. Costs are both high since it made from high purity raw material and designed to withstand high temperature without cracks or deformation.
So the next one is, so before we proceed po, meron po tayong procedure, preparation of crucibles. So I'm just going to read it po kasi hindi po namin nalagay. So number one is clean the crucible to be used thoroughly by backwashing on a filtration train. Backwashing a filtering crucible is done by turning the crucible upside down in the adapter and sucking water through the inverted crucible. Number two is dry the crucible to constant plus. So meron po kaming video po, ma'am. Dito na.
So I wanted to show you quickly how you heat a crucible.
I-share ang sound by sound ito.
Into the lid, and I'll show you that here in just a second. So here I'm heating the lid, and it's actually upside down. And the reason for this is probably not clear to you at this point, but what's going to happen when we burn our sample inside the crucible is that it's going to leave a lot of residue on the top, and your goal is to heat that residue out. Now, you may have to actually pick up the Bunsen burner and direct it to specific spots to heat it, and that'll help that unburned carbonized material release from the crucible, and then we'll be able to collect it when we do our mass. We're going to weigh the crucible with its lid. You notice I have the crucible up here cooling. It was just a convenient place to put it. But we're going to heat this lid, and then when it's all done, we'll go and weigh these two together. It's okay, by the way, if you can't get the material off of here and you're afraid you're going to spill it, to weigh the lid and the crucible separately, although we prefer to try to weigh them together, but you can weigh them separately and add their masses. But again, like I said, you may have to pick your Bunsen burner up to heat spots that aren't accessible. So the next thing I'll be showing you is how to actually, assuming that I can get this to a constant mass, how we can go about heating a sample inside the crucible.
So, babalik po tayo, ma'am. So, let's define drying to constant mass. So, constant mass drying, also called constant mass drying, is a scientific process for ensuring that samples are entirely dry. Weighing a sample before and after it is exposed to a drying agent, such as silica gel, is part of the drying to constant mass process. Before and after exposure to the drying agent, the mass of the sample is recorded. The sample is weighed again after the drying agent is removed to see if it has reached a constant mass or the same mass regardless of the quantity of moisture in the sample. So may dagdag pa po dito si Princess.
So in line with the previous explanation for defining the drying to constant mass, heating the crucible is, we all know that it is a preparation before the process for filtration method. Then, yes, there might be a leftover inside the crucible after we filter it, right? And that might affect its weight, like moist, which was mentioned also, and therefore we need to heat our crucible again. In addition, heating the crucible and its lead to constant mass in a particular reason that there will be changes in weights that vary in temperature. Excuse. If it is hot, if the crucible is hot, its weight is slightly less. In comparison, if it is cold, there would be a slightly owing the production of convection current that might affect the apparent mass of our crucible. So what do you mean by convection current? The convection current involves the transfer of heat through the fluids or liquid, and heating to constant mass after filtration to empty our crucible is an example of that, as it was completely dry. So next slide, please. Thank you.
Ma'am, saglit lang po ma'am kasi wala yung reporter. So ma'am, ipakita ko na lang po muna yung video po kasi hindi po namin mano sa planting.
Okay.
Ma'am, excuse me po. Yung yung second report ay next reporter namin ma'am ba is not present, si Crystal Plantig po. Should we proceed na lang po?
Okay. Sige, saluhin niyo na lang muna yung part niya.
Since we have error here, may troubleshoot, we will just proceed for the precipitation or precipitate.
Okay.
Ma'am, excuse po. Sorry po, ma'am.
Okay. Andito man pala si Planting. Crystal?
What is precipitate? A precipitate is an insoluble solid that forms when a liquid solution evaporates. Precipitation is the process by which an insoluble solid emerges from a solution. Frequently, the precipitate appears as a suspension. So in chemistry, To precipitate is to form an insoluble compound either by reacting two salts or by changing the temperature to affect the solubility of the compound. Also, precipitate is the name just as a result of precipitation when a compound forms, then we are shown to take out contains wastewater. If frequencies of heavy metals can be found, such compounds of sulfur hydroxide, we can apply that is soluble. That will result in
Shopee. Wala si Crystal.
Okay, may I continue, ma'am?
Okay, sige, go.
So the example of precipitation reaction in everyday life, precipitation reaction can be used in wastewater treatment. When a contaminant forms an insoluble solid, then we can use this reaction to precipitate out the contaminated ions. In wastewater, the frequent presence of heavy metals can be found such as compounds of sulfide and hydroxide. So we can add a source of hydroxide that is soluble that will result in a precipitation reaction.
So before we proceed po, may isa pa po kaming video na prepare.
Paki-share ang sound, Brian.
Sorry about this. This video is going to talk about how to filter using gravity. Filtration is a separation process. Frequently, you will have solids mixed with liquids, as you can hear, and you want only one of the two. Pouring the mixture through a filter paper, we have here, allows you to separate the liquid and the solid, keeping the solid behind and to filtrate the liquid coming through. One of the most common examples of this is making coffee. Hot water and ground up coffee are mixed, and the liquid forms a hot drink that many of us consume daily. The solid coffee grounds are not too wonderful though, so they are retained in a filter while the drinkable fluid comes through the filter and is available for consumption. There are several methods of filtering. Gravity filtration, which we're talking about today, allows separation with only gravity pushing the liquid through the filter paper. The paper is put into a funnel supported, the slurry poured into the funnel, and the separation takes place as the liquid passes through the paper itself. Filter papers are circular, folded in half, and then in half again. Take this quarter circle and open it with 3 on one side and 1 on the other, and you have a small funnel. That fits into the funnel. You'll need to have your funnel sitting above a receiving cup when using a flask here. You can use the beaker. Sometimes you may need to support this with a clamp, but usually it will just sit in the neck of the vessel. Take your mixture of solid and liquid and swirl it to suspend the solid in the liquid and pour. Be careful when you're pouring that you don't overtop the liquid as it goes through, otherwise it'll just run down the outside of the filter paper and it won't be much use. Maybe that you need to take a break and pour some more if you have too much capacity. Now, you may notice I didn't get all of the solid in the first time. And so what I need to do is do a second round on this and transfer it with liquid. The best liquid to use is in fact this one right here. The filtrate is already a sachet.
Nag-above po kasi siya. Okay lang po mga, proceed na lang po kami sa guide questions. Yung pangalawa po. Kasi nag-above.
Okay.
Next one po, si Micaela po.
Differentiate gravity filtration and vacuum filtration. Vacuum filtration, which removes particles from a fluid using a partial vacuum, and it is the second most prevalent form of filter. Gravity filtration differs from a vacuum in that a vacuum is a closed system that prevents air from getting into the filtered fluid, whereas gravity filtration is an open system that allows air to get into the filter fluid. So the difference of the two is that gravity filtration is used to separate a liquid from a solid in order to preserve the liquid substance, while the vacuum filtration used to isolate the precipitate for further processing or analysis. Next reporter, please.
Sino next?
Yung next po sana ma'am si Carla Shane Mapio po, pero lumipat na po pala siya sa 1C. Kasi next.
Okay, sige, pakisalo na lang.
For the conclusions, we apologize for not providing a soft copy for this, ma'am. No visualization for you to read, but let me narrate it. For the conclusion, the activity was familiar and easy to learn with. The links provided are also helpful, and they showed or demonstrated the proper procedures for each topic. We have also just realized that there is such a thing called gravity and vacuum filtration, and it is new to our vocabulary. We were also amazed as to how the crucible and cover resisted the heat while its appearance is just like a glass like we use at the kitchen. Well, it is not called heat resistant for nothing. In this activity, we have also tried creating and folding a filter paper with the guidance of the video link that was provided. So far, it was really easy and simple to follow. For the drawing the constant mask, that's it.
So ito po yung mga references namin po, ma'am. And that's all. Thank you po.
Okay, sige, you may unshare the PowerPoint. Okay, wait lang. Ayan. So class, this is activity number 3, the equipment and manipulations for filtration. In analytical chemistry, we do a lot of filtration processes, especially if we have reactions forming precipitates. Kapag may precipitation reaction tayo, syempre, di ba, when you say precipitate, it's a solid substance formed during the reaction, and whatever you do, this solid substance will not be dissolved in the liquid phase niya. Kahit pa you stir it or you swirl it, hindi talaga yan siya madidissolve. Now, there are times that we we need only the precipitate. So we have to separate the liquid part and the solid ones. And that's the time we do the filtration. Now, most of the time we use the filter paper, so it's very important for you to know the basic skill of folding our filter paper. Okay? And then the filter paper is being fitted in a funnel. And then doon natin ilalagay yung mixture that we want to separate. So, syempre, we can get the filtrate. The liquid phase or the liquid portion is called the filtrate. And then, syempre, the precipitate will be left in the filter paper. So, yun yung ginagawa natin for filtration. And now, if we want to have a rapid filtration process, that's the time we use the crucibles. Whatever crucible that we can use. Kasi parehas lang sila ng mukha, different lang yung kanilang material kung saan sila gawa. Most of the time, we have the Gooch crucible and the glass crucible in the laboratory. Okay, mas madali kasi silang i-manipulate. Now, before we can use our crucibles class, we have to clean it. Kailangan muna siyang i-clean through backwashing on a filtration tray. So pag sinabing backwashing, iti-turn natin upside down yung ating filter ay yung ating crucible and then isasak natin siya with a vacuum. Okay, meron tayong vacuum in the laboratory where we attach our crucible. Pero again, kung backwashing yan siya, babaliktad natin yung ating crucible and then ipapasak natin yung any water na nasa crucible natin. So i-invert natin. Then after washing it, we will have to dry it to constant mass. So I guess pinakita kanina ng reporter on how to do the drying. Either class we use the Bunsen burner. So kung nakita niyo sa video kanina, the crucible is subjected to the flame in the Bunsen burner, both the body and the cover. Okay? So if we need to invert it, we will be inverting the crucible for the inside to be dried also. And then again, also the cover of the crucible should be dried. Now, if ever we have oven in the laboratory, in which in GSDM-SFI we really do have, we seldom use na lang the Bunsen burner in drying. Instead, the crucibles will be placed inside the oven. Okay, yun na yung ginagawa natin in preparing and drying our crucibles. Now, when you say drying to constant mass, it means that we will have to do 2 consecutive weighing. Example sa ating crucible. Malalaman natin na constant na yung kanyang mass. We will be doing 2 consecutive weighing and that the weight of the crucibles will not differ sa more than 0.5 milligrams. Constant mass na yung tawag nun. So again, mag-weigh tayo, di ba? Nag-dry tayo ng crucible. After drying, i-weigh natin siya, i-record natin. And then after that, we will repeat the procedure. We can subject the crucible again in the flame of the Bunsen burner, or we can return it back to the oven. And then after some time, we will get the the crucible again and then do the second weighing. So i-record din natin yung weight niya the second time and then we will get the difference. If the difference is not more than 0.5 milligrams, yan yung tinatawag natin na constant mass. So we have dried the crucible to a constant mass. And we can use the crucible for the laboratory procedure. We can do the filtration process na. Okay, any question about the preparation of the crucibles? I hope you watched the video in the link that is provided in the worksheet. Any question? Ilan yung constant mass? It should not be more than 0.5 milligrams. in the 2 consecutive weighing. Kasi parang hindi siya nasali ng reporter, no? Yung meaning ng constant mass. Actually, nagbigay naman kayo ng meaning ng constant mass. Hindi lang nabigay doon na meron kasi siyang 2 consecutive weighing, and that for it to be called constant mass, hindi dapat mag-differ ng more than 0.5 milligrams. That is also true for the precipitate. If we are going to dry our precipitate, not just with the crucible. Now, di ba, example, nag-filtration process tayo, nahiwalay na natin yung liquid sa ating precipitate, and now we need to dry the precipitate kasi medyo wet pa siya because of its contact with the liquid portion. Pwede din natin siyang i-subject inside, ilagay natin siya in a crucible and cover and then place it in an oven. And then afterwards, we can also do drying to constant mass for our precipitate. So we will be drying it twice in a row consecutively. And then we just have to make sure that the difference between the 2 weighing should not be more than 0.5 milligrams. That's when we can say that the precipitate that we have obtained has been dried to constant mass. Okay, that's the use of the crucibles. And then we have the filter paper. Our filter paper in the laboratory is round in shape, and we have to, actually wala naman talagang mahirap mag-fold ng filter paper, no? Madali lang ito masyado. We just have to fold it in half for the first part, kasi circle siya, i-half mo siya. And then yung na-half na parang crescent moon, i-fold mo siya again hanggang sa maging letter C siya, parang triangle na siya. And then we will open this. Open natin siya. I just have to make sure na hindi open ng tuluyan hanggang sa baba, ha. So merong portion na 3 paper yung naka-cone, yung isang portion, isa na lang pag open natin. And then, we can do the letter E actually, na yung second fold is lagyan natin siya ng parang palatandaan na yan yung second fold niya, and that is where we will going to open the filter paper. Pag na-open na siya, ilagay mo siya sa funnel. And you may do the filtration na. We can separate the liquid portion and the solid ones. I hope in your high school years, nagawa niyo siya. Nagawa niyo ba? Okay, very good. So this is not really new sa inyo. Kaya lang, since we cannot do the face-to-face laboratory class, so that is the reason why pinagawa na lang kayo ng parang filter paper. Though bond paper lang siya, wala din naman kayong filter paper dyan sa bahay ninyo. And skills kasi ito, so kailangan yung mag-return demo. And that is the purpose of the video that you have to submit together with the worksheet. Okay, now in filtering and washing the precipitate class, this is through the use of the filter paper fitted in a funnel. So example, we have here the mixture. You can see there is a precipitate, the solid portion, yung brown one, and then the supernatant liquid on top. We call that supernatant liquid, the liquid in the mixture of the precipitate. Now, the first thing that we need to do is to decant. Okay? When you say decant, ipapasettle muna natin sa baba si precipitate. We have to make sure na nakasettle sila at the bottom. And then when you say decant, kung sa Bisaya pa na siya, iyabo lang na parehas na naglungag ka. Di ba pag naglungag ka after washing the rice, ginapasettle natin yung rice on the bottom. And then we are decanting the liquid na, the water na ginamit natin in washing. So that's how we do the decantation process. So this sa pagsaing class, we just don't do the filtration. Okay, diretso na nato iabo ang ato ang liquid portion. Minsan may nasasama pang rice pag hindi maayos yung decantation. Pero ito sa laboratory, so ipapadaan talaga natin siya sa funnel with a fitted na filter paper para just in case na we need to really obtain the precipitate, hindi siya mahahalo doon sa filtrate. By the way, itong liquid na ito na nakuha natin during the filtration process is called the filtrate. Okay, filtrate ito ha, and then yung maiiwan, precipitate. Okay, now after getting rid of all the supernatant liquid, we can actually do washing of the precipitate. Pwede natin siyang i-wash. Example, through the use of distilled water. Since remember, precipitate are not soluble to water, kahit padagdagan mo siya dyan ng tubig and all throughout, i-decant mo siya here sa filter paper, okay lang. Yan yung tinatawag natin na washing our precipitate. After the decantation process, syempre maiiwan itong mga solids dito, lagyan mo siya ulit ng water. And then, i-wash mo siya by swirling and then ganun pa rin, i-decant pa rin yung liquid here para mahiwalay siya. Now, if yung mga precipitate is mapunta dito sa filter paper, that's okay. Mas madali kasi siyang kunin. I-scrape mo lang siya and then we can transfer it to another container. Now, if kailangan ng drying ng precipitate, yun yung babalik ka dito sa drying to constant mass. Okay? So, this is very simple na laboratory procedure. Pero you just have to be familiar with that kasi meron na tayong schedule sa face-to-face laboratory class. And definitely, there will be procedures there that require you to do the filtration process. So remember sa guide questions, when you say precipitate class, it's the solid material being formed in the reaction. Insoluble, they are insoluble. So even if you do swirling, stirring, or even if you add more solvent or water, precipitate don't really dissolve. Okay, that's the precipitate na tinatawag. So again, mabubuo lang sila if you have precipitation reaction. Now, for the differentiation between gravity filtration and vacuum filtration, itong illustration sa taas, this is what you call gravity filtration. Kasi yung pagbaba ng liquid will just be dependent sa gravity. Wala kang tinulong. Nagdecant ka lang ng liquid and then you just wait until all the liquid will pass through the filter paper. Now, pag vacuum filtration na yan, class, kailangan talaga natin ng vacuum attached sa ating funnel nito to aid the filtration process. So, yung vacuum, isasak niya yung liquid dito para madali yung filtration process. Let me just see if I have a video here using a vacuum. Di ko lang sure. If you have questions, you can send your questions sa chat. Ito. Well, let's see. Oops.
Martina.
Blair.
Bridget. In this video, we are going to show you how to carry out a vacuum filtration. Vacuum filtration is a special type of filtration where a liquid is drawn through a filter by applying vacuum. This is generally used to collect a solid product. Here's the equipment you'll need to carry out this filtration. This is a Büchner flask, sometimes called vacuum flask. You will also need a clamp and vacuum hose, which usually has thick walls and is not very flexible. Securely clamp the flask to the workbench or a retort stand. Connect the vacuum hose to the short tube on the flask. Connect the other end of the hose to a vacuum source, which will generally be a vacuum tap or an aspirator. To carry out the vacuum filtration, you will also need a Büchner funnel and filter paper. As the Büchner funnels come in different sizes, you must check that you are using the right size of filter paper for your funnel. The filter paper should fit snugly on the bottom of the funnel, covering all of the holes. To create a vacuum seal with a Büchner flask, you must fit a rubber cone to the bottom of the Büchner funnel. Insert the Büchner funnel into the mouth of the Büchner flask. This fit may initially be loose, but as the vacuum is applied, the seal will form. Add the correct size filter paper. Turn on the vacuum. Wet the filter paper with the fluid you're filtering to ensure the filter paper sits in the correct position. Here we are using distilled water. Immediately pour the fluid into the Büchner funnel. The crude product has been collected in the funnel. Often there are soluble impurities still attached to the solid, so the product may need to be washed to remove these. Remove the vacuum hose. Add your washing liquid to the funnel and mix the product with the liquid. Reapply the vacuum to the Büchner flask and smooth out the solid in the funnel. Generally, the effect of washing is not obvious, but in this example, the impurities are a different color to the product, so the effect of washing can be clearly seen. Now we have a finished product ready for collection. This can either be removed on the filter paper or, if left to dry, can be scraped off the filter paper.
Okay, so that is the so-called vacuum filtration. So yung ginagawa niyo parate sa laboratory during your high school years, ano lang yun siya, gravity filtration. Pag wala kayong inattach na vacuum to aid the filtration process. So nakadepende lang siya sa gravity kung gaano katagal mahuhulog yung liquid doon sa receiver mo. So vacuum filtration, we really have vacuums in the laboratory where we can attach that, and then instead of using the ordinary funnel, by the way, yung ginamit nila is the Büchner funnel, B-U-C-H-N-E-R. So it is also shaped just like a cone, pero kung nakita ninyo, di ba, may mga butas-butas siya. And then you don't need to fold the filter paper when you use the Büchner funnel. Kailangan mo lang siyang ilagay doon sa circle. Yeah, pag malaki masyado, syempre may standard size tayo ng filter paper sa lab. And if we are going to use a small Büchner funnel, we just have to cut the filter paper na mag-fit siya doon sa funnel. So yun lang yung ginagawa. And then, ayun, ilagay mo na, i-attach mo sa vacuum. And then as you can see, mapapabilis yung filtration process because of the sucking power of the vacuum. Mas madali siyang mahiwalay yung liquid. Kasi sa kung mag-ordinary funnel, ordinary filter paper, maghihintay talaga tayo kung kailan siya matatapos. Especially during research class na yung mag-filter ka ng plant material and then yung alcohol, for example, ipaghihiwalay natin sila. Minsan, half day or whole day yung students sa laboratory just for the filtration process lang. So dugay kayo sila mahuman, magsige kung atong sa ila dugay kayo. That is for research purposes. We don't do that sa laboratory since limited yung time natin sa lab. Pero sila kung nagre-research sila tapos experimental ang research, Pag nag-filtration process yan sila minsan the whole day. Kasi daghan man kaayo ang ilahang gihimo and usahay daghan na pud kaayo ilahang gamito na filter paper and the funnel kay para lang jud mapadali kasi gravity filtration lang ang ginagawa. So hindi kasi we don't really use vacuum sa school. We only do the gravity filtration. So that is your activity number 3. Any question? Wala. So